disorganized. The okay. So here's the thing. I started doing this because I was pretty far behind on the problem sets that I oh. Is my mic just like doing the thing where it doesn't wanna... One second, let me reset this. Oh, also we're in just chatting because I was like, why not? Let's try it. Let's ball. One second. The easiest thing to make just How about that? It's still quiet. One sec. Wouldn't be a Davey stream without a little bit of scuff, right? That's a VTuber thing to say. God, which chord is it? This one. Does it work? Nope, it's still okay. It's still messed up. And you know, I'm just gonna turn up the gain, and then if I get really loud, hopefully somebody yells at me. Go, Damie, please. Okay, why? Okay, I'm just gonna keep making noises. It's so quiet. I don't know why. This mic is actually very scuffed. I might see if I can get a new one for the holidays, because it's so scuffed, guys. It's not a very good mic. I also... yeah, you know what? We make do. We're engineers here. What was I gonna say? Oh, yeah, so I started doing these problems earlier, because I was like, oh, I'm really behind, because I was being lazy, and I wasn't doing things, because I was like, I know what a dot product is. I don't need to do this homework. And then I did it because I was like, I should probably do it. But the consequence of that means that what I did was I got to a problem that I couldn't solve, and I said, you know what, I'm going to do this problem on stream. So we're starting off with one that it is a little bit tricky. So, alright. We're going back into vectors. If anybody is here. Hi, hello! How am I doing? I'm doing pretty well on this fine day. Who are you? I also realized that it's Thanksgiving, and people choosing to watch streams during Thanksgiving are very very kind. I don't know if you have been here before, but I've never streamed in this category before, even though I kind of like could. I just don't. Normally I stream in science and tech or something. But I was like, I'll do it today. So, welcome to the stream. I hope you're doing well. I do math. And I do physics, and I also make Among Us. I did that last time. I don't make Among Us a lot though. So, okay, for this one, I'm gonna write all the vectors in column form. I told you a few days ago, but you were offline. I was searching for a fake stream, and yeah, I saw a video of your stream. Oh gosh. That's awesome. Yeah, my schedule is kind of all over the place. Well, lately it's like been alright because I've been on break, but normally my schedule is kind of like all over the place because I have performances and like helping other people with performances for dance, and then exams and projects and all other garbage. Okay, so I'm gonna write these in column notation. Oh, you're from Germany. That's awesome. I always feel so bad when I have like well, I don't know. Trying to stream and in like time zones that make sense for the most people is hard. Like, I always feel bad because Storm will come on and be like, sorry, I have to go to sleep. It's like 1 a.m. I'm like, oh, I wish I could stream earlier. Okay, so these are 3 vectors, and they span a parallelepiped in R3. I suppose I could attempt to draw this. 1, 2, 3, 4. 2. It's only 4. Oh, view of 10 p.m. That time is completely fine. Hells yeah, it is. And this is X, this is Y, this is Z. Those are positive directions for each. So A is 1, 2, 3. So somewhere like here. That's A. B is -1, 1, 2, so somewhere like here. If I can draw the ortho projections, that might be more helpful. Oops. And then C is 2, 1, 4. This is not like great. It's not gonna be super easy to see, but so these span a parallelepiped. So there's 1, there's 2, 3. So what we can do is to find the, do I study physics and math? I do study physics and math. I have done, let's see, recap. I have taken up to linear analysis, or not up to, I've taken linear analysis basically, but I skipped multivariable. So a lot of this stuff is kind of new to me, but it's weird because it's like I'm meeting an old friend, but like they're a completely different person. Like they have like a completely different side. They started a new life. So I haven't really worked in R3, but I've worked in like RN, which is strange. And then for physics, I took 2 years in high school, which was like college level or whatever. So that was mechanics, and then E&M, so like electrostatics, thermo, fluids, quantum, magnetism. So I have like a conceptual understanding of a lot of different physics stuff, but not, I've taken mechanics like in university, like I just am wrapping it up now. So I have like a lot of the concepts to explain, like if you wanted me to explain something, but I don't have the calculus background for everything, even though I know calculus, I just didn't take it with calculus. So what we can do is, what I was thinking was, normally, like if you had 2 vectors, right, like, or if you had, this sounds like a lot that I learned. Yeah, I just, I was like ahead a year in my high school. So I took BC calculus my junior year, which I was very lucky to do because it's kind of like the same pacing as college, where like I took a year of a course and it was like basically Calc 1 through Calc 3. And then I took another year, and that was linear analysis and differential equations. But I hesitate to say that I have done differential equations because A, they're not really called that, and B, like we did very specific use cases, so we like I can't really say that I can do differential equations. Damie, it's Thanksgiving, what the hell? Well, I'm alone, so you guys are here. And I have problems to do. What I was thinking is, when you cross like 2 vectors, right? when you cross two vectors, you can get the, if you have like your vector A and your vector B, you know, you get the cross product. And this, the norm of this, the norm of A cross B, is the area of the parallelogram that they form, right? That's just kind of the definition of the cross product. So like this is this. And then all I have to do is, right, like if I have a C, I was thinking that like, if I take, right, if we have a C this way, if this is the area of one of them, then if I take the norm of C, the length of C, and I multiply this area by that, then that should give me it, right? Maybe? Yes, no, maybe? I don't know. It might be wrong. So I think the first thing is I need to do A to B and A to C to get our two vectors. Because I don't know, I kind of when I do cross product stuff, I kind of like to think of these more as points than vectors. Because it's kind of all a vector is. It's just a point. But like, we can contain it within one thing, which is a little bit nicer. So from A to B, we've got -2. Let me write this in order. So -2, -1, -1. And then A to C is 1, -1, 1. So now if we cross this, AB cross AC, this should give us this area here. Hopefully. I mean, again, I'm just balling right now. I don't know if this is right or not. This, 1, and there's a bunch of negatives, so that sucks forever. So for I, we've got -1, -1, minus -2, minus -1, plus 2, minus -1. This is 0. Wait. Wait, -1. This is -2i minus this is -2 plus 1. So that's -1, but that turns into a positive. Plus j plus 3k. And so then we need to take the norm of this, because the norm of this is the area. So that would be 4 plus 1 plus 16, which is square root of 21. Is that right? I feel like that's wrong. Let me just look at this. -1. Yeah, -1. I guess that's right. And then all we have to do is multiply by the norm of C? Question mark? No, okay. We don't multiply by the norm of C. Because we want the height, I guess. But do we want the height? Yeah, we do. So if this is the angle here... Well, I don't know. Let's do the angle here. That seems better. This would be... I want the height. That'd be sine. Unless we measure the angle... Wait a second. Do we measure the angle this way? Maybe we might measure it from the norm. Or from the... Oh, I don't know. I don't have it. Oh. I see what you can do. So... If we say... we say this is theta, then we can say that this is sine. Wait, do I want cosine? I want cosine. Would that be right? So it'd be... yeah. If we do this as theta, then this is cos theta, c norm of c cos theta. This height right here. And that can give us a dot product, I think. Question mark? Because if we say if we say a dot b, that equals a b cos theta. That's the angle between them. Yes, okay. This works. So our a in this case is this. So we have square root of 21 times b. Wait, what am I trying to find? Wait, fuck. Wait, what am I trying to find? I want to find the area. The area equals this vector, this norm, AB x AC, times b cos theta. So then b cos theta equals a dot b over a. Okay. Well. And in this case, a dot b is... or no, a is... so this equals something over 21. But how do we find this dot product? Can I find the dot product? Oh, I have c. So then a dot b. So then we have -2, 1, 3 dot c is 2, 1, 4. So this is going to give us -4 plus 1 plus 12, which equals what? That equals 9. Does that equal 9? Does that equal 9? Wait. No, this is just dot B. Ooh. So in this case, dot C. Oh my god. This should equals 9. Okay. That was the answer I was looking for. That was the answer in the back of the book. I was trying to figure out how they did it. That's weird as heck. That's weird as heck. I don't like it. I mean, I get it. Ugh. That made me take psychic damage. Okay. Because, oh, that's so much thought for that, just that one thing. Anyway. Okay. The next one. We gotta do 35 and 37. Okay. Okay, so 35 is find the volume of the parallelepiped with adjacent edges PQ, PR, and PS. Adjacent edges. What does that mean? Oh. Okay. Wait, we just have to do the same thing again. Wait, no we don't. Wait, yes we do. Okay. First off, we need to... So, in this case, like, these vectors, the PQ, PR, PS, are going to be the same as our ABC. So we're going to have to make, like, another thing, and we'll just call it, like, an easier thing. So, okay, so... Actually, no, I lied. They're not gonna be that. Because okay. No, we're fine. The original vectors were just points in space. These are just the same thing. Okay, so PQ, PR, PS are going to be our ABC. So P is, okay, I'm just going to do this. This is 4, 2, 2. Oh my god, are they going to be like linearly independent or not? PR, it's going to be 3, 3, -1, and then PS is going to be 5, 5, 1. I don't like that. I don't know why. They seem too nice. Okay. So what these are telling us is like let me think. So in this case, we had 3 vectors, and we needed to set up the vector like from here to here, from here to here, to tell us about stuff, right? To tell us about the shape of this. In this case, we have 4, 2, 2. Alright, this is a vector from here to here. Wait a second, let me think. I'm trying to figure out if I need to do a second distance between them. So this is from a point P to a point Q out in space. And in this case, this represents from a point, like, from 0 to A. So I think we need to say... But in this sense, this is like... This is saying from 0 to this point. Let me think. 1, 2, 3. 1, 2, 3. -1. PR. This is not necessary to draw this out, but I just think it's fun. And then this is PS. Okay. Yeah, I think we need to actually set up these vectors. Here and here. Yeah. So let's go from PQ. I guess we can just say PQ to PR. That's not confusing at all, right? Right, chat? This will be -1, 1, -3. And then from PQ to PS, we have 1, 3, -1. So then we're gonna cross these. So PQ, PR, cross PQ, PS equals this determinant. I should actually write it as a determinant. So -1, 1, -3, 1, 3, -1, which will equal this is -1 minus -9. Oh, let me write it like this. -1 minus +9 And then we've got 1, 1, minus minus 3, so plus 3. And then negative 3 minus 1. This is 8, negative 4, negative 4. Okay. That's our, this is equal to, and then the I'll do the magnitude as well. The magnitude of P, Q, P, R, X, P, Q, P, S. 64 plus 16 plus 16. That equals 64 plus 32. What is that? 96. Kind of nasty, but that's fine. Okay, and then we just need to cross this, or dot this with, so PQ, PR, PQ, PS, dotted with PS. From this point to this point, from this point to this point. And then PS, I think. So you can see it fits right. 8, negative 4, negative 4. Dotted with 5, 5, 1. Nope, that's the wrong one. No, it's the right one. 5, 5, 1. So 40 minus 20 minus 4 equals 16? Yeah. Let's go! It's 16! Let's fucking go! Oh, let's fucking go. Let's fucking go. Winning! Winning! Flexing! Flexing! Let's fucking go! It's flexing! I love it when I get dot products and cross. I love it when I get determinants right on the first try, bro. I trained with the blade for years for this. 1 year. 1 singular year. Okay. Oh, that's good. That's a good win. That's a good win. Okay, 37. It's gonna be another, like, parallel. Use the scalar triple product to verify the vectors. Some shit are coplanar. Bro, what the heck is a scalar triple product? Okay, let me just, like, define these first. So U is 1, 5, negative 2. 1, 5, negative 2. V is... Oh my god. Oh, sorry. I'm gonna make this a lot more clear. This is taking me back to linear algebra, where I had to, like... linear analysis, where I was like, bro, I gotta make my U's and my V's very clear. 3, negative 1, 0. And then W is ball. Although, in physics, like, because big W is work. And then little w is nothing, but omega is not W. So I try and make my omegas, like, really, like, catboy mouth shaped, so that they look like omegas and not like W's. 5, 9, negative 4. Okay, let me read up. Maybe they, like, were like, hey, here's how to actually do this, and you didn't need to figure this out. Bro, they told me how to figure it out. I didn't need to spend the time. Oh my god, I didn't need to spend the time proving that. Triple products. The product A dot BXC that occurs in property phi is called the scalar triple product. The geometric significance of the scalar triple product can be seen by considering the parallelepiped determined by the vectors A, B, and C. The area of the base of the parallelogram is BXC. Thus, the volume is the triple product. God damn it. Okay, and if the volume is 0, then they're coplanar. God, okay. I wonder if I can do them. I think I can do them this way. So we'll just say like scalar triple equals 1, 5, -2, 3, -1, 0. It shouldn't really matter because if I'm remembering correctly... No, I'm not. I was gonna say some bullshit, but it's not real. You have to know more about things to actually... Because I was gonna say something about the inverse of a matrix and its determinant, but that's only true for certain matrices. Hermitian. Oh my god. Don't even get me started. Okay. What's a good row here, chat? What are we feeling? We're feeling this one? I'm feeling this one, kinda. Yeah. So -2 times... Oh my god, wait, how is he gonna teach people this? He's gonna have to teach them about more determinants then. Honestly, I was gonna say I'm kind of feeling the -1. Because it's plus minus, yeah. So -2 and then 3 times 9 is 27 plus 5. I don't know why I put it in brackets like that. Double bracketed up. Yep. And then 4 would be plus, it's a -4. And it's a plus, whatever. So that would be -1 minus 15. So this should be... What's 27? What's 27 plus 5? That's like 32. Minus 4 times 6. This is minus 64 plus 64, I think, because this is 16. Or this is -16. Help? Hello? Oh, hello. Math. Yeah, I'm doing math. That's 0. They're coplanar. Coplanar. My buddies, all my buddies are coplanar. Math is cool. Yeah, I agree. It's so cozy doing just sitting down and doing some math, listening to some jazz. This is really you know, if you told me like 3 years ago that this is what I would be doing, I actually would say that sounds pretty good, because that 3 years ago was like COVID started. So I was not having a good time back then. Actually, was I opening my show? No, I was not opening my show at this point 3 years ago. That was later. Oh, that was before spring break. Time comes first. Vector calculus? Yeah, we're actually literally just about to start the vector calculus part of this. Teehee. Me when I vector some calculus. It's self-care. Okay, my professor said, hey guys, I did a funny little silly little goofy move here, and you know how I normally assign like 10 problems per section? Well, I assigned like 3 times the amount of that. So we have a lot of problems to do. So it's a lot. 3, 5, 16, 17, 19, 21, 27, 31, 33, 35, 39, 45, 51, 55. I'm still going. 57, 64, 65, 69. Oh, yeah, 69. That's pretty nice. Help you? Help you with what? 3. Gotta start at the very beginning. Very best place to start. We're actually doing... Okay. We're actually doing vector things. Lines and planes. I really need practice with lines and planes. I'm gonna be real. Being drowned by the vector calculus? We haven't even started the vector calculus yet. Okay. Right? We're gonna start nice and easy. Find the vector equation and parametric equation for the line. The line through the point, 2, 2.4, 3.5, and parallel to the vector, 3, 2, -1. Okay. So the way we do this, if I remember, is that when you do a vector, you have one vector to get up to the point, and you have another vector to determine the direction. That's the way I'm trying to remember it. And what that looks like is, let me scroll through my notes here. Where is it? That's parametric. Yeah, so R equals R0 plus TV. So T is our, like, actual... I'm asleep to your stream because whenever I watch, I only want to sleep. Wow, that's so nice of you to say. That was sarcasm, by the way. I hope that you meant that in a nice way. I'll just pretend that it's... I'll pretend that you meant that in a nice way. I'm just balling, dude. I don't know what to say. Okay, so this R0 is going to be just basically the vector representation of its point. Yeah, math is mathy. So it's going to be 2, 2.4, 3.5 plus t times 3, 2, -1. That's all we gotta do. Look at how beautiful that is. I love it when things are simple. So this is the vector representation. And then if we do the parametric representation, I'm trying to remember. I think that's like x equals... It's like x minus 2 equals v? Like x minus... No. How do we do it? I'm like very close to it. It's kind of just like a regular line, I think. Yeah. It's like x equals x0 plus a at, etc. So for... Let me do this. So like x equals 0 plus at, dot, dot. So we'll have x equals our initial x, 2, plus a, 3a. Yeah. Y equals 2.4 plus 2a, b. And then z equals 3.5 plus minus c. Look at that. Also really nice. I just need to burn this into my brain. Because I have not done this a lot, so... Hopefully there's some more line stuff in here that isn't just, like, distance to a line. But I don't really mind if it is... Okay, 35. Okay, perfect. The line through the point... So we have a point. And perpendicular to the plane x plus 3y plus z equals 5. Oh, do I remember planes enough? There's a normal hidden in there somewhere. Where's the normal hidden? I think the normal might just be 1, 3, 1? One, 3, 1? Oh. Yeah. If I choose... Wait a second. So... The plane equation is like... You know, a times x minus x0 plus b times y minus y0 plus c times z minus z0 equals 0. So if we have a plane that's like this, No, I want to do the other way. Okay. Let me think. If I had A equals 1, like, or if I had, like, you know, like A1, 1, 3, 1. Do I need a point on the plane? I don't think I need a point on the plane. I think the normal can just be normal 1, 3, 1. We'll check it. If it's wrong, it's wrong. The normal is the vector that defines, like, it sticks straight up out of the plane or straight down out of the plane, and it's perpendicular to it. So that's how we can determine the direction of the plane. So, like, if the plane is facing this way, the normal would be facing out that way. So what I'm trying to do is I'm trying to find what this vector is from this equation, and I think it's just the constants. I think it's just the constants. So what this is asking is we need a perpendicular thing to this plane. So the normal is perpendicular to it. If for some reason it was asking parallel to the plane, we could just take a dot product equals 0 and then solve that out. So then the vector way of writing this would be r equals 106 plus t 131. And then the non-vector way of writing this, let me recalibrate my tracking for a sec. Here's my tracking. Why is it so jittery? Hello? Okay, I'm restarting my YouTube studio. Sorry, gamers. I don't know why it's doing that. Getting in on the fun of the R3 space. So x would equal 1 plus a, and then y would equal just 3b, and then z would equal 6 plus c. The blank stare. Oh, turn on the anime girl? Well, once my tracking is fixed, give me 2 seconds. I don't know why it's doing that. I mean, I can turn on the anime girl. Maybe she will fix it. Probably not. Oh. Everything's falling apart. It's fine. Cat girl does vector calculus? Yeah. I was cat boy, now I'm a cat girl. Am I pressing hotkeys? Is that what's up? Or is it just lost tracking? Huh. Whatever. Okay. Okay, let's see if this is right. It'll be very, very simple to see if these are right. 3, 5... 1, 3, yeah, okay. Nice. 1, 3, 1. At gender neutral does math. Non-binary cat does math. That'd be based. Incredibly specific niche of VTuber. Cat people doing math. That's mine, baby. That's my niche. Good niche. I like it. I like it here. Okay, 16. Find parametric equations for the line through that thing. Non-binary bean. Okay, so point is 2, 4, 6. And perpendicular to the plane, so we got a normal, which is 1, -1, 3. So we want parametric equations for this. So x is going to equal 2 plus a. Vector Hector, I banished thy math with my almighty specter. That's funny, because the whole point is math. I mean, you're welcome to attempt to banish the math. I think the math is more powerful, though. In what points does this line intersect with the coordinate planes? Okay, the coordinate planes is like x equals 0, z equals 0. The worm demon you made overthrew you? I don't know what that means. 69 points. Well, no, it's gonna intersect at like forever points. We know it won't actually. So when x equals 0, a equals -2. Remember the worm demon. I don't remember the worm demon. When z, this will be like, because I think it can be anything. I do not remember the worm demon. When x equals 0 and z equals 0, that's x equals 0. That's the y plane. So y can be anything? Or -2 y 2? But y would have to be 0. Oh, I don't know. I don't know. My brain hurts. He oversees? Oh, did you just put him like somewhere now? No? Nope. I'm gonna assume that I just forgot. Oh. I'm back. Intersects with the coordinate planes. And of course I can't check it because it's 16. That's an even number. We can't check even numbers. Okay. Let me think about this. Think really long and hard. In this case... What is this? This is a plane, so it's gonna probably intersect as a line in certain places. So if we're looking at this coordinate plane, x can be anything, and z can be anything. So this one right here, we'll just do this. This is y equals 0. This, y can be anything, and z can be anything, so this is x equals 0. And this one, y can be anything and x can be anything, but so it's z equals 0. So in this case, if we have like x equals 0, that means a equals what are you, a fox, cat, angel, boy, girl? My brain, I'm an angel cat boy. I feel like I think that's in my bio. I think that's in all my bios everywhere. So a equals -2. So this would be a line. What is a? X equals -2? I think. What am I looking for? Shomo? What am I looking for? Oh, you mean like in the problem? Oh, I was like, what is happening? I'm just looking for the points of intersection with the coordinate planes. So this is with the, if x equals 0, then a equals -2. In that case, I need to just like do this in my brain until I get it. So if a equals -2, what does that mean? That means that like this coordinate in this vector, this is always 2, but this is b and c, so they can be whatever they want. That means that like if this is the x, this is the y, this is the c. That means that this always has to be here. But that's a plane. I don't want a plane. I just made up a plane. I need the intersection of this plane with that. Wait. Wait, no. My brain turned on for like 2 seconds and then it turned off again. Okay. Okay. I'm thinking so hard. When you want something to intersect, you plug the thing into the thing. Which I get. But in this case, like, z and y can be anything. But if I want to get a line, it should be a line. Like, wait, can I just say like a equals -2, y equals 4 minus b, z equals this? Or like b equals, maybe I can write a little bit better. Like b equals y minus 4. Can I just write? Because isn't that a line? Isn't that a line? When you only have 2 variables that are changing? Or is that a plane? No, that might be a plane. Oh, my brain. I think I'm gonna have to graph this on GeoGebra. 1 second. I almost said GeoGuessr. Not what I meant. Okay, let's see. Let's do a little graphing. We do a little graphing? Here, you guys can see it too. Oh, it was capturing the... Okay, so we have x equals 2 plus a. No, I lied. Wait, do I want 2 plus a? Oh, thinking so hard right now. Wait, I don't want it to be a. I want it to be like... Like x0? Y equal, I'm just gonna write this out. 4 minus b. No, see, but this is like turning them into different things. Discord is hard to find on Twitch. Like my Discord, I have a command for it. Yeah. But you're in the Discord. Oh. Here, let me... Oh, where's my rolls? Rolls. There you go. I forgot I have an Urple roll. Most people put it in their bio. Yeah, I could. I need to do like a revamp of my layout and stuff, so... How do I write this so that it turns out as a plane? Because right now this... Okay, let me write it like as a vector instead. Can I use vector notation here? Or can I do column vector? How do I add a vector? Can I not add a vector? Uh-oh. Oh. Vector? What? Oh. 3D? Bottom? What? Also at the top of the class is the all-seeing math demon. I named him Bob. Bob is cool. That sounds awesome. Plane. Whoa, plane. Oh. Okay, so I can put in stuff. I would like to put in a line though. Where's a line? Am I losing my mind? I'm losing my mind like just a little bit. I'll put in a point and a line. No, a point and a vector. Can I put in a point vector? Uh-oh. No, I don't want that. I just want to put in a vector, please. How did I do this before? Oh, I think I just put in points. Okay. Okay, I'm not doing this right now. That's not happening. We're gonna skip that. Because I can't even check it. Like, that's silly. It's fine. It's fine. I'll just circle it and, like, ask in office hours. Or this next one will just tell me. Will just end up showing me how to do it. Okay, find a vector equation for the line segment from something to something. Okay. So the point in this case is, so our point P can be either of those points. So I'm just going to choose the 6, negative 1, 9, 1, because it's kind of like 69. And then the vector is the vector from the first point to the second point. So 1, negative 1 to 6 is 7. And then 9 to 0 is negative 9. So if we want the line segment, we want to say, right, if we were doing the whole line, this would be like R is equal to... I think we want to say R is in between two things. Like, we have like our R, and then it's in between two things. But how do we do that? What two things? Oh my gosh, hi Riches! How's it going? What's up? It's been like 1 million billion years. I followed you on Twitter. But like only once Twitter like exploded for some reason. I picked like the worst time. I saw you in Shrimps like mentions or something. Not mentions. in Shrimp's like comment section, and I was like, hey, that's Rich's. I should follow him. Yeah, I don't know what Elon did. I forgot he bought Twitter. Yeah, for real. He kind of bunged it up. What would this be in between? I want it to be in between 2 points. Thinking so hard in my brain. Wait, no, we just constrain T. Omega lol. It's fine, I'm normal. I say omega lol and then people beat me up with hammers. That's how real life works. I followed you on my art account, but not on my private. Then I saw your follow request. I was like, OMG, hi. That's me. It's me on Twitter. Dude, I don't tweet like ever. I like forget to tweet. And once I stopped doing schedules, I like totally forgot to tweet. Like I just don't tweet. Okay, so at the lowest, we want T to be 0. So T is in between 0. Nah, for real, I only retweet. So true. I think T between 0 and 1. Yeah. T between 0 and 1. I just like stuff and then oh, is my mic like... It looks like my mic is so loud right now. I love technology. Calculus, oh. For real. Okay, bring it down to 4. Thank you, Mike, for being the worst mic ever. We're just chilling. We're just balling. What is a matrix? A matrix is a bunch of numbers and then they have gay sex in there. That's like a bedroom. A matrix is kind of like a room with gay people in it. If you think about it, really. A matrix is just a way to say a bunch of numbers quickly, basically. It's like an array in programming. It's like a bookshelf, kind of. If you will. There are many ways I could describe matrices. 17. Yeah, T's in between 0 and 1. Let's go! I'm so smart for that. So smart for constraining T. So smart. So smart. My Sigma male mantra. If Patrick Bateman solved matrices, he would have been fixed. That's all I'm saying. Determine whether they are parallel, skew, or intersecting. If they intersect, find the point of intersection. How can you do this? I think you can just row reduce stuff. I was good at math last year, but my pre-calc class is actually killing me. Like, I don't get it. Oh. What part do you not get? Oh my god, how am I gonna write this? Okay, we'll do this. I'm thinking so hard right now. Everything? Oh. This is our point. It's 3. How did I do this? I did this in my notes. Let me look real quick. Formulas and half-life. Oh, half-lives. Okay, I don't blame you for not getting half-lives. Formulas are like, if you don't understand a formula, that's like, all right. If it's a specific formula. Because sometimes they just have use cases that are confusing. But if there's a concept you don't get, like if you were having trouble like with logs or something, then that's like something that you can get help with. Because like you don't use half-lives like in math, you just use them to do half-lives. And it's also, it's just a formula you can like put into a calculator. You'll never have to like do that by hand. What was I looking up? Oh yeah, when I did the linear algebra way. How did I do it? Where did I do it? Where were we checking if they were skew? I put in the things like get logs mostly, but that's like the one thing I did okay with on the test. Oh, sometimes they're tricky. I had a lot of trouble with logs. That's why I mentioned it. I also had trouble with trig when I first started out. Now it's like I get it a lot, like I get it a lot better. I can kind of take control of it a little bit more. Man, I'm so upset that I didn't get taught trig in a better way. So how am I doing this? So I can check if they're parallel first off really easily. Do I want to write them like a point? I guess I could write them like a point. The way that I end up writing them... You're proud of me? Oh, that's so sweet of you. I'm gonna have to think of a way to linear algebra this. We'll do that later. First, we should check if stuff is parallel. First, I should write down the problem. So you guys can see. Instead of me just saying numbers. Oh, 1, 2, yes, very math. It's when you get to you get to a point in math where you don't even need to see the numbers anymore. They just appear in your brain, and then you can transmit it to your professor, and that's how they grade your tests. Actually, you don't even. I mean, for my last midterm, like we just sat and we closed our eyes and we thought really hard, and then our professor just like gave us our grades like right there. So it's a little bit of a little known fact, you know. Yeah. You kind of have to get used to it. It's a little bit scary the first time because you don't want to send over any thoughts that aren't math, you know? You only want to send over the math, so it can get a little hard. Think fast? Yeah. You gotta think really fast. You gotta process up there. So line 2. I don't know why I wrote it like that. 1, 3, 4, 4, -2, 5. Honestly, one of my favorite things about doing linear algebra is like, it is so lovely to not have to just write a bunch of random shit down that you don't need. Because, like, if you look at this, you're like, this is X, this is Y, this is Z. If I was trying to write this out, like, without that, I have to go X equals 3 plus 2t, Y equals 4 minus t. That's so lame. That is so many strokes for just 3 numbers. I broke? I break a lot. If you're my model. It's because my tracking, like, my camera's not very good. We're a little scuffed. We're a little scuffed, little cat boy. Okay. So just by looking at these, they're not multiples of each other, so we want to see if they are parallel or not. And to check if they're parallel, we can check. How do we check that? Good question. Oh wait, no, we have to check if they're intersecting first. Or no. Wait, they're not parallel because they don't have the same vector. We need to check if they're intersecting, which is just setting them equal to each other. Question mark. Meow. Let me check. I did this a little bit ago. So what we can do is set up a system of equations. Oh, there's a storm? Oh no. So let me actually write this out like the boring way real quick, just so I can see how to equate these. Z equals 1 plus 3t. Because I haven't done this, like, and I would like to get a nice little take time to set up my way of doing this. So normally in linear algebra, we would have like x plus y plus z equals 30, you know, 4y plus 7z equals 2, and like that's our linear algebra, and this translates to a matrix that's like, you know, 1 1 1 30 0 4 7 2. In this case, we have x equals something, y equals something, z equals something. So what I want to do is either I don't really want to have a matrix that's like putting the t's in there, because that would be bad. So I think what I need to do is I need to equate them first. So 3 plus 2t equals 1 plus 4t. So then we have 2 equals 2t. Wait, is that right? No. How do we do this? Oh, because they're not all t. I think. This is... Wait. Is it RST? I think it's RST. Okay, that makes a lot more sense. Lol. So then what I can do is... Wait, maybe no, I didn't do that. I think I did this. Let me make this S. I think I did it with like that. And then that would be 3 plus 2s equals 1 plus 4t. So then you have 2s minus 4t equals negative 2. And then we can solve it. Yeah, I'm down for that. So what we have to do is we have to look with our eyes, and then... So we match them up. So this will be like 4t minus 2s equals... So it'd be this minus this. Negative 2? Wait. We set them equal to each other. 4t equals 2. Is that right? Wait. I'm trying to go too fast. 4t equals the... Move this over here. That's a minus. Okay, yeah, 2. Then we have 4 minus s. We'll keep the same convention where like the t's are... it doesn't really matter. So negative 2t plus s equals 4 minus 3, which is 1. And then we have our z, which is 5t minus 3s equals negative 3. And then we can turn this into our matrix, which is 4, negative 2, 2, negative 2, 1, 1, 5, negative 3, negative 3. And then we row reduce it. Yay! Everyone's favorite. Everybody remember RREF? Back from the old linear algebra buddies. Oh god, this is gonna be nasty. No, it's not actually. Wait a second. It's gonna be so kind to me. No, it's not. No, it's not. This might be the worst possible way I could have done this, but we're gonna just go for it. Okay, so row 1 divided by 4 is gonna give us 1, negative 1/2, 1/2, 2, 1, 1. Oh god. No, okay. We're okay. For the first one, we're okay. Because we're gonna do row 2, plus 2 row 1. That'll give us 1 and 1/2, negative, or 1/2. This will be 0, 0, 0, 1, 2. 0, 0, 2. Then we have 5, and we want R3 minus 5 R1. This will be 0. Okay, -3 minus 5 halves. -3 plus 5 halves is... Plus 5 halves is what? What is that, chat? This is a 6? Wait. 6? 11? But, like, I think it's 1/2. Is that right? It's minus 1/2. Yeah, I don't have to do any more calculation. Then that's fine. So we just do like row 3 minus row 1. Actually, we're getting out of this kind of scot-free. This will be 1. Bro, it's so nice. Wait, uh-oh. No, it's not. I lied. Can I explain work done on an incline? So I guess, like, I don't really know exactly what is doing the work, but like, anytime you have an incline, you want to think about changing like your axes to these axes, right? So in this case, like, okay, gravity. Okay, perfect. So in this case, our gravity goes down like this, right? We know that, let's just say like there's like a ball here. We know our gravity goes down, right? Like that, but we don't want to do that because it's easier for us to look at forces like on a flat plane. So what we're gonna do is we know that this is theta. We know that this is theta. So what we want to think about is, we know work equals like force, the cross product, the dot product of force and distance. So we need to get a distance, but we can figure that out. We need to find a force. So in this case, our force is mg, right? Or like that's what we think it is. But we need to find the component of the force that's acting in whatever direction is what is it called? Not orthogonal. Which is parallel to the direction of motion, right? That is in the direction of motion. So we know that the larger F is our force, but we need to find a component of it that goes this way. So we need force parallel. And in this case, right, if this is our theta from here, this is just geometry. You'll disappear after this quarter? Wait, no, I don't want you to disappear. You can still stick around. I do coding too. So in this case, we want this component right here. So that would be, what is that? That should be adjacent over. Adjacent over. So that would be cosine, would it not? F cos theta? Am I lying? Is it F sine theta? There's no place for me in any sooner or later. Aw. Well, you're welcome to stay if you'd like to stay. 2 more weeks and I'm done. I'm also... Am I done in 2 weeks? I am done in 2 weeks. That's weird. I leave for my break on the 10th. My second break. My schedule is very strange. This is kind of weird. Why is this doing this? I think it's F cos theta. it doesn't always have to be goodbyes, but if you need to go, I'm not gonna force you or anything. So this would be just the... Maybe it's good for me? No, bro, you always ask me questions and then I answer them, and that's good for me, because if other people have the same question, then they can also listen. So this would be like, you know, the component, and then you multiply this by whatever distance the ball goes. So let's say, you know, if you're given like a height, sometimes they'll give you like a height like 4 meters or something, then you just have to use trig to... You highly doubt it? No, I don't doubt it, because I literally have explained like calc stuff to other people and they're like, oh, that's a good explanation because of the questions you ask. So okay, this is not good because 0 doesn't equal 2. So that might just mean that they don't intersect. Let me check to see if they don't intersect. 19. Skew. Okay. So yeah. Asking questions is so important. And asking questions is very useful for me, because then it helps me lecture better. Okay, so if I get anything that's like 0, I'm just gonna be done. This is automatically skew. Because I already checked for parallelness. Which is nice. It's nice that I don't have to go any further than that. Okay, what was the next one? What was that one? That one was 17? 19. It's 21, okay. Oh god. Oh no! Oh god. They'll no longer... Yeah, but like, you can stick around and do coding stuff. You have coding classes, right? You're a comp sci major. I know computer science. It's a little. Why is this saying X? Oh. Okay, I'm gonna write this one out. Do I know any Swift? Bro, I skipped out on Swift. I am... Okay. So... Okay, where do I start? My school, my high school had a computer science program, right? As, you know, as high schools do. Some high schools. But it wasn't very good because I lived in like the New York area, and so what would happen is all of the people who were good at programming wouldn't go to schools to teach, you know, programming. They would go program in like New York or wherever else. So we didn't really have that many teachers who were like good at comp sci. And so what happened was we had this one class that was like, you know, app development, and it was taught in Swift. And I was like, okay, I'll take the AI course instead. I'll take the other thing. But like, I don't know. That was the only class I took. Every single other class in the comp sci department at my school, I didn't do Swift because I was like, I do not want to program for Apple stuff. That was the only thing. I only do it for money. Hey, that's fine. As long as it fulfills you. I mean, like, when in my orientation class, they were like, you know, like, why do you want to, you know, major in mechanical engineering or whatever? And one of the things on there was like financial security. So like, if having money will make you have a good life and you want to do the job because, you know, computer science or engineering or whatever, because like, you want to have money, then that's perfectly reasonable. Too much bitter but no sweet. I love engineering. I would get so bored in comp sci. I'm sorry. But it's because my dad is a software engineer, so I feel like I also worked... I did comp sci for like 9 years. More than 9 now, probably. Wait. Yeah. Like almost a decade. And so I feel like I've already like been there, done that, sort of. Obviously not worked in industry because I was a child, but sorry, I had to take a sip of my drink and then I die. Okay, so this is... I like engineering because you get to do comp sci, but in kind of more inventive ways than just, like, developing software. Or I guess not more inventive, but more varied ways, I should say. Although software development is very cool as well. There'll always be a special place in my heart for software development. Why is this saying, like, over? This is weird. It's 4/3. Why is it saying over 1? Well, so for this method, I wanted to write out... well, let me, like, multiply everything out. We'll do that. This will be 6x. Yeah, we'll multiply by negative. So negative 6x plus 12 equals negative 6y. No. Positive y. Or 3y plus 9 minus 9 equals 2z minus 1. What is this saying is the thing that I'm wondering. Okay, I can do this the regular linear algebra way, which will be negative 6x minus 3y minus 2z equals... Wait, can I do that? Can I do that? Can I combine them all? At the very least, I can do these two. And then we'll figure out how to get the z in there. I think I might need to substitute in for a z. Ugh. That's annoying. 3y. This would be negative 20... No? Yeah. 21? I don't like that. I don't like this problem. I don't know why. It gives me bad GBs. Why is this so... like this, is the question. It could be trying to hide the fact that they're parallel. Which I'm sure this book is not immune to. Trying to be sneaky. Maybe if I leave, I can stop coming back? Well, I mean, if you want to leave, you could leave, but, you know, I appreciate your presence. If I do the, like, oh, it's because there's no parameter t. I don't know how I feel about that. Maybe there's an example that does it this way. Let's see. Might be like, hey, silly head, here's the thing that you're doing. Here's the thing that you're trying to do. We just put it up here. No, it's not. Oh, wait. Wait. Oh, there is. There is a thing. You only have to bear with me. Bro, I'm not bearing with you. You're just like, well, we're vibing out. You're a regular. Of course, I'm not gonna like hate you or anything. Oh, here we go, here we go, here we go. Okay. So in this case, this would be x equals 2 plus a. Y equals 3 plus 3 minus 2t. 2b. z equals, okay. And then we can do our little z equals 1 minus 3c. And x equals 3 plus a. Y equals minus 4 plus 3b. This equals 2 minus 7c. Okay, nice. So our normal vectors are not the same. Or not our normal vectors are. Direction vectors aren't the same, so we don't have to worry about them pulling a fast one on us there. And then, oh. I already forgot. Self-constrained optimization in vector calculus, last chapter. That sounds awful. I don't know what that is. Oh, I just called them all the same thing. Can I do that? Oh, yeah. Okay, we'll use R and S then. Well, I'm glad you're almost done with math, because you seem to not particularly enjoy it, so... Shouldn't be a problem. Yeah, I just don't really like optimization. It kind of makes my head spin. Okay, so for the first one, we'll have... If you're good at linear optimization... I don't even remember. That's like the min-max stuff, right? Like finding this point to say like this is the max second derivative. I don't know if that's what you're talking about. Because the stuff where it's like, oh my god. Somebody was asking about this in the Discord. They were like, oh, what's like the biggest rectangle you can fit in this like oval? And I'm like, I literally remember so clearly my teacher doing this proof for like this this problem, and I don't remember how to do it at all. The global min max in multi-calc are insane. It takes 15 minutes to solve a problem. Oh no, bro, I'm gonna perish. Although that is kind of how linear algebra was. It's like, okay, here you go, time to write out numbers like this for like the entire period. You're not done yet. You're not done yet. Oh, and then you have to write out, then you have to write it out like this. 1 minus lambda. And then you have to just keep doing this. Forever. It's so annoying. I kind of love it though. I don't know. I like doing it better than having to write out a bunch of... It problems like find the shaded region in the circle for max and min. No! I'm not looking forward to that particularly. Okay, so we've got R minus S equals 1. And then here we'll say negative 2R minus 3S equals negative 7. And then we've got negative 3R plus 7S equals 1. Finding all the critical points can be painful. Oh, yeah. Oh, because you have to just take the first derivative and you have to solve, like, the equation, right? Okay, this looks like it's going to be not too bad, I say. Yeah, this should be okay. Because we're going to do R2 plus 2R1. We'll do R3 plus 3R1. You have to take the first and second partial derivative of x, y, z. Ooh, yum. Yummy. Then you list all the max and min values. I'm kind of excited. Apparently my professor is like a funny guy though. I don't really know how I feel about that. Um, okay, that's good. -5 is good. 0 and then 7. This will be -4, and then that'll be 4. Okay, this is looking good. We're just gonna divide this by R2 divided by 5. This is looking like it'll be intersecting. But you can use Lagrange multipliers to solve them. I don't know what that is. I hope it's not that bad. I'll do -5. I could just divide this by... Have I tried integral of the day on Instagram? Oh, I have not. That sounds neat. R1 minus R2 plus R2. R1, R3 minus R2. 1, 1, 0, 1, 1, 0. Nope. 2, 1, 0, R3 -2. I think this means that they're skew. Alpha is where you learn from Lagrange. Oh, yeah. So, I actually do know a little bit about this. Because, like, I overheard at the office hours for my professor, he teaches like a bunch of different classes. So he teaches linear analysis this quarter. And so he had linear analysis people coming in to ask him questions when I would be like just hanging out. And they were talking about lambda because in linear analysis, lambda is what's called an eigenvalue, or also like an eigenvector. And this is something that you can like multiply a matrix by. Like it's a vector that you can multiply. So if you have like a matrix here and you multiply it by an eigenvalue or an eigenvector, it like becomes it like stays itself. So this is the one that I was referring to, but the more new symbol I see, the more bit I can swallow. But I heard that there's another lambda value. They also use it in half-lives. 4 variables in 2 equations are really crazy to solve. That's why it takes so long. Yeah. I just like it. But like, I think it'll be fun. I don't know. I'm excited to take like, I just really hope my professor like teaches concepts and not just like shits out stuff. You know what I mean? I trust him, but 21. Uh-oh. I must have done something wrong. Because apparently there's a point that they intersect at, so... It's not so fun when all the materials are involved in 1 hour exam. Yeah. No, for real. I had my last math midterm was an hour, or my math midterms were an hour, and they were like short, but they were intense. Oh my god, all the triple integrals? Bro. Oh, I heard, yeah, my professor was like, I didn't even give you guys like the hard he was telling other people that he like didn't give them like the long stuff, because our finals are 3 hours, but our midterms are only 1 hour. Unless you're like my physics professor and you're like, come in at 7 p.m. at night and take it, which is what he did. Triple integral for center of mass in a sphere. Whoa. That sounds dope. I'm gonna be real. Okay. This is R minus S. This equals this. R minus S equals 1. That's right. Gross. Yeah. -2 minus that equals -7. Yeah. -3 plus... What did I do wrong? Okay, we're gonna check the work. This plus 2R1. This plus 3R1. So... -2 plus 2. -3 minus 2. -5. -7 plus 2 is 5. Yes. -3 plus 3 is -7 minus 3 is +4. Seven minus 3 is +4, and then 1. Yeah, okay. We divide that by that. Do that. This will be 0, 0, 0. And then you have, what is that? X equals 2, Y equals 1, Z equals 0? There's a lot of crazy geometry mixed in. Oh, with series? Oh. This is not correct, by the way. Oh, no, it's because X doesn't equal that. It's S equals that. So S equals 2. No, R equals 2. R equals 2, S equals 1. So then X equals 4, Y equals -4, -1, Z equals -5. Yay, that is right. Like elliptic paraboloid? What the? Quadric surface? Bro, I am gonna be, oh my gosh, okay. I love like using math terminology to describe stuff, especially because my roommate is an English major. They're majoring in English to go into like English education, like to be a teacher. And so I love using math terms to describe things and like people and stuff, because no one understands it. Like I have no friends who are like, oh wait, that's not true. I'm not around a lot. I don't live with other engineers or people who like are math stuff. So I'm so excited to get into Calc 4, if only for the reason that like I think like parallelepipeds are so silly. It's just such a funny word to say. It's like, guys, I don't know, I'm feeling kind of parallelepiped today. And people be like, what the fuck, Davey? Don't say that. Like, you know what? It's the only way I can describe it. Sometimes you just feel like a parallelepiped. I think it's stuff for preparing for topology. Yo, that sounds dope, honestly. I really wish, okay. I do, part of me like wish it, I have to take Calc 4. Yeah, so we have Calc 1, 2, 3, 4 here, where Calc 3 is like series and sequences, Calc 4 is multivariable. And then we have linear analysis 1 and 2, and I have to take up to that. Which makes sense, because linear analysis is just matrices, and it also makes a lot of math stuff easier, and like AI, like all that stuff. And then part of me kind of wishes I could take real analysis here, like at this school. So I might just take it for like funsies. Can I explain a parametric problem? Yeah, like just the idea of what parametrics are. Sure. So a lot of times the Cartesian plane falls short, right? And we can see that in a lot of different scenarios. You know, like in polar coordinates, it makes a lot more sense for us to describe things using vectors like this. Like when we have like a... Oh, there is a problem you have. I got you. Let me see if I can do it. This image. Let's take a look-see. Oh, it's so pixelated. Which one? Oh, just the power series? Yeah. Damie, I'm back from Thanksgiving dinner and you're still live. This is my dessert. How are you back from dinner? It's 3 p.m. Okay. So the goal of this question is to estimate the value of the integral using a series. Note that one can use partial fractions and trigonometric integrals, but they take a lot of hard work and not going to be considered valid solutions. All right. So we want to find the power series representation of the geometric series. So It's 5 p.m. here. Oh, okay. That's valid. So one of the things you need to know about power series is that if you have a power series like, if you have a power series like x to the n, which gives well, let's say if you have a function, I don't want to say this. Okay, if you have a thing x to the n that gives you a power series, wait, how do I want to write this? Oh, it's leaving my brain. If you have yeah, we can do that. So if you have a function that's like 1 over 1 minus x that gives you this power series, you can put in like a function, right, that's like, if you put in f of x here, that'll give you the power series of f of x to the n. So that's really important. So you can substitute in things. So we're going to break it down into steps. So there's a lot of things going on here. We want to make this look like this. So the first thing is we want to divide everything by 8 on the bottom, or we can pull out an 8. And this becomes 1 plus x minus 2 cubed over 8, right? So the blue answer is incorrect. Let me see. I'm just gonna do it out real quick. So then you have, 1/8 times, and this will, I'll just skip right to the power series then. So this will be negative 1 to the n, x minus 2, 3n over 8 to the n plus 1. So I think everything is correct except that since you factor out this 8, I think you have to put in the 8 to the n plus 1. So yeah, because this turns into like, if you didn't have this, you have like times 1/8, so n plus 1. How do I craft Rod of Ages? Huh? Is that Minecrafting? And then for radius and interval of convergence, all you have to do is say -1 to the n plus 1 times x minus 2 to the 3n plus 1 over 8n plus 1 times 8n over -1n, x minus 2, 3n. It's an old league item, and then we absolute value this, so these are going to go away. This goes away. This goes away, so we have x minus 2 over 8 is less than or equal to 1. There's a limit here. Yeah, you ratio test, and you have to say that it's less than or equal to 1. And so then you have x minus 2 is less than or equal to 8. So then x is going to be equal to 10, and or this is absolute value of x minus 2. Which is, my brain is frying. What is that? 6? I think? Yeah. And then we can check, wait, your interval of convergence, what was it saying? Is the interval 2, 3 included? No. Wait, it should be though. This isn't easy? Wait, let me... So x minus 2. The absolute value of x minus 2 is less than or equal to 8. That means x is less than or equal to 10 and 6, right? Negative 6? I think it's negative 6. I think it's negative 6. I'm trying to remember how absolute value works, bro. So then, yeah, 2, 3 would be in this interval. And we want to find an antiderivative power series function so that f prime of x equals that. Okay. Oh, consider convergence at endpoints. Bro, I forgot about convergence at endpoints. Then you plug in x and you say, okay, what is this? When x is negative 6, that's x is negative 6, that'd be negative 8 to the 3n, negative 1 to the n. The negative, this 8n plus 1. This becomes 8 to the 3n over 8n plus 1. Does the limit of this go to 0? The limit of this does not go to 0, so get fucked. This one has nothing. And then if it's 10, then that's 8. I don't think either of them is. I think they're both open. And then if I find, so, okay, sorry. Let me pause for a second. Let's pause. This is the answer to the first part, right? This is the answer to A. We found a power series centered at 2. I did not write. You wrote n equals 0. Like, good job. Then the second part is we find the interval. This is the interval of convergence, right? So if we want to find the radius of convergence, we have to say what's the difference between these two, and then divide it by 2. Or in this case, like r equals, I think r equals, is it 8? Or is it 9? What does part C even mean? Okay, I'll get there in 1 sec. Let me just finish writing this part because we do need the radius of convergence as well. This is our interval. Our radius of convergence would be 8. Okay, and then part C is saying, so find an antiderivative power series function f of x of this so that the prime of it is this. So we just have to integrate this thing. 8? Yeah, the radius of convergence is 8 because from negative 6 to negative 10, that's 16, and then divide that by 2. That just means like how far out from the from 0 are you? So if we go 8 this way, 8 this way. Or from our, because we center at 2, right? So this is 2. We go 8 this way, 8 this way. That's all the r means. So if we want to find an antiderivative, I guess there are 2 ways we can do this. Never mind, there's only one way we can do this. We have to write out the terms. So for n equals 0, we're going to have x minus 2 to the 0th over 8 to the 1. So that would be 1/8. And then we're going to integrate it. Plus, when n is 1, this will be negative 1 times x minus 2, 3 over 8 to the 8 squared plus positive x minus 2 to the 6th. Once we get a couple of these, we can maybe start to see a pattern, but we'll just start out by writing a bunch of them. Negative 1 times x minus 2 to the 9th or 8 4th. Okay. So change this to 1 over 8. Can't we just take the integral directly? I think for the most part, you want to do it this way. I mean, this is the way I've always done it. Just because, I don't know. I don't know why I always do it this way, but it just kind of makes sense to me to do it this way. So this would be 1 over 8 squared. If we take the integral of this, that's x minus 2 to the 4th over 4. Yes. Plus x minus 2 to the 6th over 6th times, to do this, 7th. You can take the integral directly. If you like feel better doing that. I just do it this way. I don't know why. Times 1 over 8 to the 4th. So then we can start to see, okay, our pattern is going to be, we have a -1 to the n, and we have over 8 to the n plus 1. Then we have x minus 2, n to the 3n plus 1 over 3n plus 1. That was the worst sigma I've ever drawn in my life. Okay, yeah. And then there's n equals 0 to infinity. Can I explain another problem? Yes. Let me see. Let me open the original. Maybe this is bigger. Oh, it's so much bigger. Okay. Win. Okay, let's see. Whoa, I said, why does it say fat? Okay. So fill out the following table of derivatives for 4 points A, B, C, D on the curve. Make sure that that any of the 2 points don't match in all 4 derivative signs. What? What? Oh. What? Oh, okay. Sign. Okay, so if we do dx d theta, this is just a weird curve. If we do dx d theta, that means that we are, what? Dx d theta is just... Wait, but this is like... Oh. So x is like r... is it r cos theta or r sine theta? R cos theta. So then x equals, right, sine theta, cos theta, cos 3 theta. And then you take the derivative of that. And then y is, this gives you dx d theta. And then y is r sine theta. So you have y equals sine squared theta, cos 3 theta. And then for dr d theta, you just, this gives you dy d theta. For r, you just do dr d theta. And then you, for dy dx, then you do, I think it's, oh god, there's like a specific formula. It's like r cos theta minus r sine theta, r prime sine theta plus r, I don't know. That's how you get the different stuff. Now the question of the question. Fill out the following table of derivatives for 4 points. Okay, so you can choose any 4 points, which is good. I don't know, you could choose like here. You could choose there. You could do, what would be another good one? Like here. I would say like here, here, maybe here, or maybe here, like there. This is a little weird, but we can go and look at it on Desmos. Let's do that. They did say to look at it on Desmos. Site capture. Oh, I need to put in my little bounds here. Fuck yeah, Desmos. Fuck yeah, Desmos, indeed. Oh dear lord, that's gross. There we go. So then, what we can do is like... I will just graph, we can say... dr... Whoops. d theta? No, we can't do that. What we can do, though, is... dx? Wait, how do I... dy dx? I might be able to just switch this by cheating. I might be able to cheat here, is what I'm saying. No, it's not gonna let me dy dx in Desmos? These problems are even grosser than physics energy problems. It's not that bad. I just wanna... Wait, why am I... Wait, why can't I... Hello? How... Why am I forgetting how to do this? DDX, thank you so much. You are a lifesaver. Okay, it's gonna tell me... Oh, okay. I have to put the DDX first. We're getting there. We're getting there, chat. There we go. Okay. Can I just do that with thetas then? I wonder if it's gonna let me. Sometimes it only lets you do stuff with x's. Yeah. Oh. Whoa! Might need parentheses. Okay, yeah. This is the derivative. So this is no. This is the... Let me make a note. This... How do I make a note? Okay. This is, x equals r cos theta. So the derivative of this is dx d theta. So that's that. Then if I do this, and we do, instead of this, we do sine. This is the derivative of y. What the fuck is the blue? This is the derivative of y. This is y equals r sine theta. So the derivative of this is dy d theta. So this is, okay. This equation right here is x, so x equals r cosine of theta, right? We know that. That's polar coordinates. So what I did was I took r and I multiplied it by cos theta, right? And then I took the derivative of it. So if I put a point in, like let's say I want to pick the point like theta equals 45. Is that not gonna let me do that? Okay, I can't do that. Let's say, let's just go along and like find a point on here. Wait, can I not slide along it? Okay, wait, I can if I click on it. No, I can't. Fuck, what the heck? Okay, we can do that. We can do a cheat. What if we say r equals 1? Can you give me an intersection? Desmos, are you gonna do this? Oh, Desmos. Oh, Desmos is gonna be a little bitch. That's so silly. Okay, fine. But we can kind of see, like, okay, so like at this point, like that's where the derivative equals, can switch to polar grid. Oh, I wasn't in polar grid. You're so real for that. Oh, it still doesn't let me click. We can see a little better though, at least. But so we can see then this is like what you're filling out on your box, right? You just need to find this. So this graph, if you put a point into this, like you say theta equals, I don't know, theta equals like 2 or something, whatever it'll spit out is the derivative at that point for dx d theta. So then for this one, this is the derivative of this is dy d theta. It kind of looks like a I'm not gonna say, it kind of looks like a rocket ship. Then if we want to do this, we can say r equals, this one is pretty easy, dd theta. This is the derivative of, this is dr d theta. Note, this is dr d theta. And then if you were to put this over this, right? So d, should I try it? I'm gonna see if it gives me anything. This is dy, right? D theta. So if we take that and we divide this whole thing by dx d theta, that's dy dx, baby. That's dy dx, baby. Holy shit, that's crazy. You can see where it's undefined. It just goes out forever where it's undefined. Oh my god, that's kind of ballin'. So we can see on these oh my god, that's crazy. On these main points, like the 30-degree increments, it's gonna what the hell on earth? Okay. This is just graphical representations of stuff. I used to do this all the time. So like what this is, what all of what this is saying, this is dy dx. Oh, I need to make a note. Dy dx. This is a visual representation of, so okay. What I used to do on Desmos all the time was like, if I had a derivative to check, right? I would put, let's say I wanted to find the derivative of, you know, x cubed plus 4. And I wasn't sure if like, with my answer, if I thought my answer was right or not. So let's say I had like, you know, let's say I had 3x squared, right, as my derivative for that. I was like, oh, I don't know if this is right. So what I would do is on Desmos, you can say d dx in front of something, if you put the parentheses in, right? And it'll give you the derivative, right? So you can see this red right here is the same as this blue. So all this is doing is saying like you can take the derivative, right, as a function and show it as a function. So what I did was, if this is our base function, right? This is the one that looks like the thing. If we set x equal to our x thing, right? R is just a dummy variable. R doesn't really matter. That's just to show it graphically. And we take the derivative of x, then this is what that derivative looks like as a graph. So if I were to plug a point into this, if I were to say like theta equals, you know, 45 or something, or in radians, like, you know, pi over 4 or whatever, it would give me the right number. So if I said like, you know, pi over 4, it should give me a, okay, Oh, I said 3 pi over 4. I lied. Okay. No, it gives me nothing because I did it silly. But I should be able to... I can't even think the instant after looking at this graph. Yeah. I just think it's funny to look at. Because you can see like, oh, at this point, right, the derivative of y is like, it's 3, which is kind of crazy. So at pi over 2, when y, for the derivative of y is 3, which is kind of cool. And you look at this and you're like, whoa, that's really crazy. And this kind of makes sense because like dy dx, right? Like we saw that y has that 3 there. We know that x looks kind of weird, but... And then this looks insane. But this is just because there's a lot of places where the function is undefined. So in the same way that like if you look at, you know, like a logarithmic function or something like e to the x, like it's gonna go up forever. It's just kind of like that, but it's all the way, it's everywhere in polar coordinates, which is not something you get to see every day, which is kind of cool. And when you do it like this, you can kind of like really see where those 2 infinity points are pretty clearly. I mean, that's like very clearly like pi over 3 and stuff. That's kind of fun. It's kind of funny, silly. It's cool if I can actually understand it. Yeah, yeah, I think you're supposed to just use a calculator for this question. I'm gonna be real. Like, just do some derivatives and kind of calculate it out. That's fun. I like that. All right, I think I'm going to wrap up though, because I'm a little sleepy. I don't have anything to do. I guess I could keep going, but I kind of don't want to do more line stuff. Although those are rousing success the last time that it did work. Like this did work. Where's my like, I'm very happy this worked, but are you sleepy on these questions? Yeah. I kind of like vector calculus. I think the only thing that's kind of trippy to me is like the concept of derivatives in vector form, because like we were doing a proof for what were we proving? We were talking about proofs for speed and the unit tangent vector, and the idea that like if you have a line like r equals r0 plus tv, that the derivative of this is v is really weird. Like, I mean, I guess it makes sense because you're like doing like dt, like ddt or drdt, and like t is your variable, and so like this is a constant. But it's just like, it trips me up so hard. Like vectors are constants, I guess. I mean, they are inherently constants, but it's just I kind of don't think about them like that, because I guess when I think about vectors, I think about them as representing a system that is filled with variables. But I guess that's like the matrix way to think about it, so. All right. I think I'm gonna wrap up for today. I hope you guys have a really nice day. If you're seeing family, or you've already seen family, or you're not, hopefully you can eat some good food, or not. And I hope everybody has a good time. I'll be back Saturday. I have a problem set to do. I will probably do some of it tomorrow off stream, just so I can like get jump started on it. But yeah, that was awesome. Thank you for coming by. Also, thank you for saying DDX. Oh my god, I definitely would have forgotten that. I would have been like, how to Desmos derivative. Anyway, it was lovely hanging out with you guys. I will see you on Saturday. Bye.